stoichiometry. Okay, so by the end of this presentation, you should be able to answer the following questions. Alright, so stoichiometry is all about making things, which is the whole purpose of chemistry. So we want to know if we're starting out with certain substances, a certain amount of substances, how much product can we get? So, first step is always to balance your equation. So I have 2 here, 3 here, 1 here. So this reads 1 mole of nitrogen gas will react with 3 moles of fluorine gas to produce 2 moles of nitrogen fluorine. How many moles of nitrogen gas must react to form 1.45 moles of nitrogen fluoride? So, dimensional analysis time. Start with what they give you. 1.4 moles nitrogen fluoride. You really need to start writing your compounds, because when these get longer, you're going to need to know what compound you're working with. So then I'm going to look back at my chemical equation. For every 2 moles of nitrogen fluoride, so I'm going to put this down here, I have 1 mole of nitrogen gas, so that will go on top. So my moles of nitrogen fluoride cancel. I'm left with moles of N2, ooh, that's a 2. So multiply across the top, divide by what's on the bottom, and I get 0.725 moles of nitrogen gas. Okay. How many grams of water will be produced if 3.5 moles of oxygen gas react? So again, I need to balance my chemical equation. So I get 2, 17, 12, 10. So I'm going to start with what they gave me, 3.5 moles of oxygen gas. And I'm going to use my balance equation to go from oxygen to water. So this is my molar ratio. 17 moles of oxygen gas gets me 10 moles of water. So my moles of oxygen cancel. Well, I need to go from moles to grams, so I need molar mass of water. So 1 mole of water, there's 18.02 grams of water. My moles of water cancel. And multiply across the top, divide by what's on the bottom. I get 37.1 grams of water. With sig figs, I would round that to 37 grams. Okay. How many moles of hexane must react to produce 13.4 grams of carbon dioxide? So I'm going to use 13.4 grams carbon dioxide. And I need to get to hexane, moles of hexane, so I will need to use my molar ratio, so I need to convert this to moles. So I'm going to use molar mass of carbon dioxide, which is 44.01 grams. If you don't know how to calculate molar mass, you need to come to tutorials. So that cancels. From my balanced chemical equation, I know for every 12 moles of carbon dioxide, I have 2 moles of hexane. C6H10. So my moles of carbon dioxide cancel. Multiply across the top, divide by what's on the bottom, and I get 0.051 mole hexane. Alright, first step, always balance your equation. This one just happened to already be balanced, so we want to determine the mass of potassium bromide. 1.94 grams of hydrogen bromide react with potassium hydrogen carbonate. Okay, so I'm going to start with what they give me, the 0.94 grams hydrogen bromide. And so I need to go from grams to moles because I want my molar ratio. And the molar mass of hydrogen bromide is 80.91 grams per mole. Hydrogen bromide. Oops. So my grams of hydrogen bromide cancel. I want moles. Well, I want determine the mass of potassium bromide. Okay, so I know for every 1 mole of HBr, from my balanced equation, I have 1 mole of KBr. So moles of HBr cancel out. I want mass of potassium bromide, so I need my molar mass of potassium bromide, which is, for every 1 mole of potassium bromide, I have 91.92 grams KBr. Okay, so that cancels. So then multiply across the top, divide by what's on the bottom, and you get 1.07 grams of KBr. This is the longest it will get when we're doing these, okay? Determine the mass of the water produced. Okay, well, I'm still going to start with what they gave me in problem A, because I have to start with something. And I know for sure I've got this. Alright, I still want to go to moles, so I need my molar mass of HBr. So that cancels. And I want water, and I know for every 1 mole of HBr, I have 1 mole of water. That's what my equation tells me. So that cancels. But I want mass of water, so I need the molar mass of water. 1 mole of water is 18.02 grams of water. So that cancels. Alright, multiply across the top, divide by what's on the bottom, I get 0.209 grams of water. Okay. Alright, limiting reagent. So just because you have an equation doesn't mean you're always going to get the maximum amount of product. There's always going to be a limiting reagent, which will limit your product. So if you have 0.303 grams of calcium bromide reacting with 0.15 grams of aluminum phosphate, how many grams of calcium phosphate will be produced? Alright, so first, again, you always need to balance your chemical equation. So we get 3, 1, 2. Alright, so the easiest way to do this is just start with the grams they gave you of this one and go to grams of the product they want, which in this case they want calcium phosphate. So this is our product. This is what we're trying to make. So 0.03 grams of calcium bromide, which I spelled wrong, of course. And I want to know grams of calcium phosphate. So I need my molar mass. So 1 mole of calcium bromide is 199.81 grams calcium bromide. That cancels. From my equation, I know for every 3 moles of calcium bromide, I have 1 mole of calcium phosphate. Okay, so that cancels. But I want grams. How many grams can I make? So I need my molar mass, 1 mole of calcium phosphate. Gives me, I have, my molar mass is 309.97 grams of calcium phosphate. Yeesh, I ran out of room. I always do. Alright, so that cancels. Multiply across the top, divide by what you have on the bottom, and I got 0.16 grams. Okay, so that's how much I can make if I have that much calcium bromide. I need to do my aluminum to see how much my aluminum can make. So my aluminum phosphate, I'm going to go to grams of calcium phosphate again. So I need my molar mass of aluminum phosphate, and which is 121.95 grams of aluminum phosphate. So those cancel. From my equation, I know for every 3 moles of aluminum phosphate, I have 1 mole calcium phosphate. That cancels. And again with my molar mass, to get to grams, I get, when I multiply across the top, divide by what's on the bottom, 0.19 grams. Okay, so I'm not going to be able to make 0.19 grams because with my calcium I can only make this. So this is my maximum product. So calcium bromide is going to limit how much product I can make. So my calcium bromide is my limiting reactant, or reagent, whatever, I'll say both. All right, so we want to figure out how much calcium sulfate we can make. So we still need to balance our equations. And we get 3, 1, 3, 2. So I'm going to start with 0.12 grams of calcium fluoride. CF2. And I want to go till I get to grams of calcium sulfate. So my molar mass is 78.01 grams. CaF2 each. 1 mole. CaF2 cancels. From my equation, I know for every 3 moles of calcium fluoride, I have 3 moles of calcium sulfate. That cancels. For every 1 mole of calcium sulfate, I have, molar mass is 136.08 grams of calcium sulfate. So when I multiply across the top and divide by what's on the bottom, I get 0.21 grams. Okay, so I need to do it with my aluminum. 0.73 grams of aluminum sulfate and go to grams of calcium sulfate. So I need my molar mass of aluminum sulfate is 342.15 grams of aluminum sulfate. I should have picked smaller compounds. I'll run out of room again. Okay, and from my balanced equation, I know for every 1 mole of aluminum sulfate, I have 3 moles of calcium sulfate. So that cancels. And then again, my molar mass of calcium sulfate. I'm running out of room. I get 0.87 grams. So this is a smaller number, so this is the maximum amount of product I can get with this chemical reaction. So calcium fluoride, is my limiting reagent. All right, percent yield. So percent yield is your actual over your theoretical. Your actual is what you get by doing your experiment. Your theoretical is what you get from your balanced equation. So in theory, with this equation, I can produce, 100% of my product. But in my experiment, maybe I only get 15% out. Well, then that's probably not a good process to use when I'm doing my product, so I need to come up with a different equation. That's what chemists do. So what is my percent yield if 13.1 grams of CaO is actually produced when 24.8 grams of calcium carbonate is heated? So first we need to balance our chemical equation, and this one just happens to be balanced. So I need to figure out my theoretical yield first. So they said 24.8 grams of calcium carbonate was heated. So I need to go to grams of calcium oxide, because that's what they want to know, how much of this we can produce. So my molar mass. So 1 mole of calcium carbonate is 100.02 grams. And for every 1 mole of calcium carbonate, I have 1 mole of calcium oxide. And for every 1 mole of calcium oxide, the molar mass is 56.01 grams of calcium oxide. So this cancels. Multiply across the top, divide by what's on the bottom, and I get 13.89 grams. So in theory, this is what the equation tells me I could produce. But when we actually carried it out in the lab, we only got 13.1 grams. So I need to calculate my percentage. So actual over theoretical, divide those, and then multiply by 100 to get your percentage. and you get 94.3%. So if you want to make calcium oxide, this is a pretty good equation to use. Alright, if you can't answer the questions at the beginning of the video, then please watch the practice video.